It's indeed an honour to be elected as a fellow to this august body, and I trust that my participation will add to the reputation and the honour of this body going forward. So when asked to prepare the few slides, it was keep it short, keep it simple. And I think someone's already said, as engineers, they follow instructions. But I've got a very busy slide. Who am I? Where did I come from? Well, from the age of 5 or 6, I wanted to be an engineer. I wanted to build bridges. And I loved engineering. My father wasn't an engineer, but wanted to be an engineer. His father was an engineer. But he took it upon himself to take me to every engineering project that was being built, every dam, every bridge, every rail tunnel. You know, and I had Meccano, I had Lego, and I had the run of the back shed to build whatever I liked, billy carts and cubby houses, you name it. It was the perfect childhood to grow up focused on wanting to be an engineer. Funny, I was one of 5. I'm the only one who was an engineer. But unfortunately, I have 5 children myself, and I've only got one engineer out of that as well. Something strange going on there in the genes. Anyway, I was able to get into Monash University and studied civil structural engineering there. I then graduated and went off to New Guinea and worked up in the highlands of New Guinea on the Octetti project, where one day I'd be designing something, next day it'd be built, or the other day I'd be on a helicopter flying out into the rainforest, walking through the jungle with the surveyors, saying I want the road to go here, here, here. Next day back in the office with the surveying data, draw up the plans, next day out directing where the graders and dozers were going, and it was just fantastic, a great experience. I came back to Melbourne and continued working with Bechtel, and my old prof from Monash University rang me up and said, "Hey Andrew, wouldn't you like to come and be my research assistant in ocean engineering and study your masters at night?" I said, "Sounds like a good idea, why not?" So threw in my project engineering role and went to Monash University, and I had a ball, just loved it. I was running the wave tank, I was building instruments for offshore data collection exercises, and then I'd be on ships going out to install these things. I spent time in the CSIRO research boat, the ESSO vessels that I would be running off on helicopters to install anemometer stations all around Bass Strait. I had a great time. And then life got serious. I found a beautiful woman to marry. We got married and we left to England 10 days later, and I ended up picking up a UK Department of Energy Research Fellowship at the University of Reading, which was a strange area, looking into mooring systems. Mooring systems? Well, at that stage, the offshore oil and gas sector was moving into floating production systems, but they didn't know how long their moorings would last. It was a new area. It's not like a ship mooring, which you throw an anchor out and it lasts maybe 2-3 days. You had to put out this mooring in the most nasty sea states in the world, and hopefully it would last for 50 years. Of course they weren't, and they're still not, but that's a really interesting area of research which we continue in. But what it meant was I had a great time. I was paid by the UK Department of Energy to look into a whole area of work, identify where the gaps in knowledge were, and produce a prospectus for a large joint industry research study, which was then funded by all the oil majors in the world. And basically we've developed the long-term endurance design basis for mooring systems. And they still form the body of the codes today all around the world. Anyway, university life was far too enjoyable, and I then moved into consultancy in the offshore sector with a company we'd been collaborating with from the university. And then from there I came back and set them up in Australia to work on the Sydney Harbour Tunnel. And after a few years we parted way and I set up AMOG Consulting. AMOG, it's not the name of my cat, it's Australian Marine and Offshore Group. And it's been going, it started in my back bedroom, and I started with 3 professors from Monash University who I used to work with at Monash, and we've gone from strength to strength ever since, and we've got offices in Houston, Bogota, London, around Australia, and in floating production systems, there's I think 290 of them in the world. We've worked on about 130 of them, all from Australia. And we're still in the area leading the development of the leading codes of practice in that area. Still doing research, joint industry research projects with universities, with the oil majors all around the world. It's really exciting stuff. And you can do that as a consulting engineer. How great. So we do lots of things, high-end advice, have lots of fun, but in our world, you're dead in 5 years unless you keep at the leading edge. So we invest heavily in R&D within the company and also in collaboration with other research organisations, which includes universities. And we develop patents and we develop software, and it's all the sorts of things which improve our business but also lead into opportunities in the manufacturing sector. Okay, and I can talk for hours about what we do. It's just so much fun. Challenge number one, which I was asked to point out to the year 2030. Well, I think it was very cosy in the engineering profession to when everything had to be done in Australia and you had a bit of a closed shop. But that's not the way it is. Certainly in my area, in the international oil and gas sector, you have to be competing with everybody around the world. So you've got to be the best at what you do. So the real challenge I see for the engineering sector is that we need to be able to maintain our relevance in a global marketplace. And that means, sure, there's commodity engineering, which is, there's a large part of the profession fulfills that space. But if you want to be in the international marketplace, that's not going to cut it because the lower cost countries will do that and you'll be irrelevant. So we've got to find out what are the areas that we can be relevant, and that means we must foster and grow high-end capabilities and technologies that will differentiate what the Australian industry has to offer around the world. And that also means looking at areas of niche expertise and together with protecting the IP that we develop through our research, be it within your company or in collaboration with universities or with CRCs and so forth. In the world, you're not going to undercut people by offering the same old, same old. You've got to find your niche and you've got to be commercially attractive and you've got to have an advantage. So that's a challenge, I think, which faces our industry. Two, I think you're not going to fulfil that first challenge unless you have a supply chain of high-quality engineers. And that means attracting the best students, male and female, into STEM. Okay. Why is it that the numbers of engineering students is not growing as fast as you'd like? Because engineering doesn't offer a well-paid career compared to the financial services sector. And they love having engineers as their new graduates because they're numerically numerate. They know how to frame a problem. They can research things. Why aren't they going to engineering? Because we don't make it attractive. We don't make it whereby there's good remuneration. We don't make it so you should go off and get these higher qualifications because you'll get a better reward path once you go out and into industry. Let's think of it this way. In engineering, you're all engineers. You're in the medical profession, you have your GPs, you have your specialists. Legal profession, you have your QCs. We don't have that in the engineering sector at all. And there's no differentiation in remuneration associated with that. So we need to actually change how the engineering profession is viewed and remunerated with that in mind. And that's my last point there. Third challenge, renewable energy. I've moved away from the professional structure, but we need to actually transition our energy sources to a sustainable low-carbon technology. And that's going to require long-term investment and bipartisan political buy-in. We've been involved in many different renewable energy technologies, and a lot of them get money, and they're not well thought out. Their technology readiness level is low, but they get support. They're fashionable, they make a feel-good headline, but they're actually hopeless technology. And when they fail, they actually reduce the reputation of that sector. So I think as engineers, we need to actually say, look, we need to go through this in a far more structured manner and make sure that the investment there is well spent. And I think out of that, there is a challenge that can create entirely new industries for Australia, which is based on niche expertise with long-term export potential. Thank you very much. And that's my final slide, which is my vision for working with ATSE is I think the strategic plan that ATSE has developed has identified many of the future challenges. To me, engineering is an exciting and stimulating career, and it will solve many of the technological challenges confronting our society, nation and the world. So how does ATSE actually contribute to that, and how can I see myself contributing to that? I think we need advocacy for leading-edge Australian engineering. We need to build and retain sustainable capabilities in Australia, and we need to advance technology in engineering. Not the same old, and I think we also need to champion renewable energy sources, particularly those which can grow the industry sector in Australia and take it to the world. Thank you very much.